OK, so let's move fast, because this presentation is quite long. First of all, this is not presentation about Cassandra per se. It is about reliability and how we do reliability in Codewise, which is quite interesting company from the perspective that we have no operation teams there, only software developers and me. First, fear question to you. Yeah. That's the fun. If you're gonna see how fun is that. First question to you guys: how do you learn about reliability? Give me some answers. Experience, yeah. In production, yeah, exactly. Join those answers, and you've got the answer the hard way, I would say. Yeah, yeah. That's actually the way we usually learn. And the thing is that if you would like to be an reliability expert, then in agreeing to Niels Bohr, I brought him because I studied I studied physics, and I like this guy very much. He told this sentence some long time ago. I think he told it. Maybe I just found it on the internet. But let's say he told it, that the expert is a person who actually committed mistakes in the very wide area, all possible mistakes. OK, cool. We can agree with that. That would be an expert. However, then, how pilots of, let's say, gliders could become an expert? I mean, it's hard to commit all possible mistakes in this area and then become an expert. Yeah, I brought it here because my friend of mine from a company, he took us there, and we were flying with him, and that's awesome. I mean, I totally recommend this thing. There are plenty around Krakow, and yeah, it's so cool. So, but I was very interested, so I was asking him so many questions, and then he told me, he yelled at me, Maciek, stop talking to me during takeoff and during landing. I have to be like 100% focused on what I'm doing, so stop, please. And then I thought, when I have outage on production and when I'm working on something, then usually there are some people around me, and they are not stopping talking, they are talking and talking. Yeah, so that's quite funny, because he told me that, and now I'm talking to everybody around when we have this outage on production, stop talking to me. And another thing which I liked and we can learn from them is, like, even though he flies a couple of hours per week, he has to pass technical exams every year. So even he is very proficient in flying, and he is a record of this that he's proficient, he has to pass technical exams in terms of being a pilot. And he flies usually alone. So it's not like about his own, I mean, it's not about security of others, but about security of him, mainly. And we, as IT engineers, let's say, do we have any kind of reliability exams or something like this? I mean, I know that you guys usually learn the reliability-related tools when there is an outage, not before, when it is already there. So we're getting in, and then we are learning, how to use this tool, because I wanted to check something. Yeah, it would be cool to have something like this, or maybe some workshops or whatever. Thankfully, these days we can learn the reliability. I mean, we can buy experience, or we can learn it in some kind of virtual environment. We have virtualization, we have containerization, we have any otherization. So yeah, it's very good to actually use that. Not many people run reliability-related scenarios on virtual environments before, but we're gonna get there in a few slides. So, how many of you knows this book? Raise your hand, please. No hand, wow. Why I'm bringing it here is because, as I told you, reliability is not easy to learn. Actually, you usually learn it year by year by year. It's learned with, it's actually tough with experience, with years, with time. And we can buy this time. I mean, we can buy the experience. This book is like this thin, or even thinner, and it was published 10 years ago already. And one of co-authors, John Allspaw, John LCD? Oh, okay, whatever. John Allspaw. He is one of the persons who started this whole DevOps movement. So he knows his shit, I would say. I mean, in this book, you're gonna find how to work in cloud. It was 10 years ago. AWS services was just rising then. They wrote how to work on database reliability, on application reliability, how to work on monitoring on the back-end side, and also on real user monitoring on the front-end side. He wrote about CI/CD pipelines, etc., agile infrastructure, whatever that is, etc. 10 years ago. I mean, it's a weekend-long book, I would say. So please do read it if you are a software engineer. Whatever. I mean, whether front-end or back-end, not important at all. But what I also wanted to tell you in this slide is that this book, I would say that it's a book created for engineers. It's not for any particular type of engineer, front-end, back-end, database, whatever engineer. And I personally think that extraordinary engineers are not focused on one just narrow area. Those are people who can work with everything, and they understand how application is hosted, how it works on production, and why this front-end works this way and not that way. It's not about learning every possible framework and deeply understanding how it works. It's just about knowing the whole big picture. So yeah, please do read it. Okay, back to Codewise. I'm not here to sell Codewise at all. So it's like 2-3 slides because you have to know the things behind that before I start talking about how we worked on reliability. So 2, maybe 3 years ago, can't remember, they approached me and told me that, hey, Maciek, we've got this situation when we are like company of 100 people and we are growing up to 300 people in like a couple of months. And we do reliability related stuff in our way, let's say. And we would like to keep the reliability, the level of reliability the same as it was. I mean, basically, right now everything works fine, and we would like to keep it this way. And probably when we hire 200 people, something might break. So yeah, we need an expert here. And so in order to buy you, we can tell you that we've got 400,000 requests per second. Is it something that interests you? Wow, yes, I mean, wow, I don't even know if I can handle that because it's a very huge workload. And they had like 1 up to 2,000 virtual machines on our environments. So yeah, that's the scale. Quite interesting. So I said yes, and then I hop in. Yeah. No ops company. It looks like this is the operations guy, and everything around is so new and so wow. I mean, the first day was like CTO told me, Maciek, find yourself a job. There's plenty of job. You are the expert. You're gonna find it. We're gonna meet in 1 week, and we're gonna discuss what you found here. Okay, so I found there are no ops, and that means in practice that all developers are on call. All. Just from some day, after 3-4 months, they get on call. Yet though, they created own database. I mean, it's an anti-pattern. You don't create own databases. Yeah? And they also created own monitoring solution. You don't do that. I mean, nobody does that. And they also self-host Cassandras and etcd. I mean, they host Cassandras being 100% on AWS services. They don't use DynamoDB. They use Cassandra and they host it themselves. Wow, why? I mean, why? So yeah, we're gonna get there later. So I found some operational threats. The first one, actually, I'm finishing it right now after 2 years of work, was Cassandra. Cassandra as a database, distributed database, it's hard. I mean, it's a very interesting database. And the thing was that I had to explain business people that we have this component called Cassandra, which is very important for every other service, but 1 or maybe 2, and that we need to push work there. So I did some research, and then I met with them and told them, okay, guys, so how do you, we've got this database. Oh yeah, Maciek, we've got this. So how do you think, how fast can we recover when it's offline? I mean, when it's gone, totally gone. Oh, it's like 20 minutes, maybe 30. No, guys, actually, it's 6 hours, maybe, in the very positive scenario. Wow, magic, it can be there, it can be that. So yeah, so this is the first issue in this Wonderland, and there were many others. So the more I understood, the more WTF question I was asking myself. I mean, what's happening? Where I am even? However, after 2-3 weeks, maybe you can remember, I kept silence, I kept low, trying to understand, because there were some really great ideas behind all of those. And me, as a production engineer, systems engineer, etc., I know how to do things, but not this way. It was something completely new for me. I wanted to understand. And then I understood, finally, after a few weeks. Guys, keep things very simple. So, for instance, they use auto-scaling groups in 100% actually of instances, auto-scaling, well, not 100, in majority of instances, auto-scaling groups and elastic load balancers. So basically, those are services that keep your services, keep your applications up, and those services are managed by AWS services. So they don't do that. They just, they are sure that their virtual machines will be up and their applications will be up. And the whole complexity of it all is that they have applications hosted, put as jar files to virtual machines, and that's all. It's very fucking simple. Nothing can broke but Java itself, like out of memory or something. And they do performance tuning based on instance type. So no containers, almost, no container schedulers, because there was no need for that. These times, container schedulers like Kubernetes, etc., are very popular, and they have place where they should be used. For instance, if you would like to host yourself cross-cloud on GCP, on AWS services, on Azure, on your own data centers somewhere, it would be cool to have the deployment model the same, so Kubernetes would be the perfect way. Also, if you are hosted in AWS services or any other cloud, 100% like we, but you would like to make it in a cost-effective way, Kubernetes might be the way. It's not like it will be, it might be, because it needs some operational, it has some operational overhead, and you need to pay for that, pay for people's time. And we didn't have that, because in order to do our deployments in a cost-effective way, we created application. It's called Spotty, that basically keeps all our workloads on spotty instances, spot instances. Those are the instances that are very cheap, but they can be brought down in like a couple of seconds, with notifying you before that happens, actually. So, yeah. So we keep things very simple. And guys learned their reliability lessons the hard way. Something stopped working, like whole S3 wasn't working. S3 is a disk, let's say a network disk provided by AWS services, and we base on that very, very much. However, if it stops working, and it shouldn't, then all our applications are down. So now, after a few hours, it's better. It's not like S3 is out and we are out. And the same applies to many, many other services. So then I realized that this is a 100% DevOps company, meaning people talk to each other, they trust each other, and they listen to each other, they commit mistakes, and they learn on those mistakes. And they move quite fast in those terms. And they don't call me a DevOps engineer. That's very important for me. How many of you are DevOps engineers here? 1, 2. OK, you are saved. Normally, at this point, I ask people to get up and repeat after me, I will not call a DevOps engineer anyone again. Only 2 people, OK, you are saved. You can't buy DevOps. DevOps is not a role. DevOps is approach, how we work with each other. So if you have DevOps engineers in your company or you are yourself a DevOps engineer, then please do Google for DevOps anti-patterns, enter and read that. Because maybe, just maybe, your company or you are filling the wrong gap. There shouldn't be things like DevOps. It's a job that is not focused at anything at all. Those are people who does everything and nothing. So yeah. Back to SRE. 2 books. Left book about learning reliability engineering stuff. Both were published by Google's. Left one is a huge book, and it's very hard for me. I mean, quantum physics related books I wrote on studies were not that tough for me like this one. But that doesn't mean you shouldn't get through that. That just means that I had some problems with quantum physics. So please do try at least go through the index. And the right one was published a few years later, and it's a practical book. So you can start with the right one. But I'm a very lazy person, so I tried to read those books, and then I finished there on the Coursera course. It's like 40, 50 bucks course, dollars. Books created by Google's. I think, Googlers, and it's like 2-3 hours per week, at least for 1 month, maybe 2, something like that. So yeah, this one should be the least approach related to reliability things for developers. I mean, just take it. I'm not selling it, however, because I don't have anything from that. But I know that you will learn many things from there. Another thing is Charity Majors. She is a great person who has so many experience in reliability work and in reliability world. She co-authored this database reliability book. So if you are hosting your own database for some freaking reason, please do read it, because you are probably not thinking about a couple of things that will happen to you in the future. Or if your engineers, your database engineers or production engineers, however you call them, do host database themselves, make them read this, or at least send this book to them. Awesome reliability engineering. This is a GitHub project. It's a last slide, I think, about those kind of things, where to learn from. By Dustergon, guys, I met him personally, cool guy, and he created this many years ago, and there are many in the index, there are many contents related to reliability, and if you click one, then you get like, this number of this long list for every of those. And actually, after this slide, I could tell you, okay, so this is ends. I mean, you know how to learn the reliability-related stuff. So yeah, but we're gonna get more. What is SRE all about? For me personally, it's about understanding how our customers feel our products. Basically, whether it works fine or it doesn't work fine. This is the first thing. And the second thing I would say is whether we are committing enough reliability-related work, enough meaning not too much, not too less. Just the perfect amount. And that's a very hard question. So this is all what site reliability engineering is about for me. Probably Googlers would tell many more things. Yes, and at Codewise, about SREs. In Google, they have SRE teams, meaning there is developer team which works on some service, and after this service is ready for production, they just put it, they give it to the SRE teams for hosting this service on production. But before they actually put it there, they have to fulfill the reliability checklist. It's a list of requirements. This, for instance, this application have this kind of monitoring, this application has this and that, blah, blah, blah. And then when it's fulfilled, SRE takes it and, okay, we put it in production and it works. But when it stops working, and it stops working in a way that is not described by procedures, we can actually take you guys, take you developers, and you are helping us with this. Also, you are on call, so you're going to help us. Works similar in Facebook. There is production engineering. There are production engineering teams there. It's called this way. And at Codewise, developers are on call, so they are SRE, so they are on call. CRE stands for Customer Reliability Engineering, and it is actually there are a couple of things which are important here, and which why I'm broughting it here. First of all, actually, this is the most important. The reliability is the most important feature of your application. Whatever you think, whatever your business thinks, if you get this, and if everybody understands this, then you are cool. Simply because if your application doesn't work because of reliability-related stuff, then it basically doesn't work. Your customers can't use it. So, yeah, please do understand this. The second thing, that users decide reliability, not you, not your monitoring. If your monitoring tells that it works for you, then you don't answer your customer, it works for me. Then instead of that, you are asking him, okay, so where are you working from? Because maybe our monitoring is badly deployed on South Africa or something, and it just basically doesn't work there because our DNS doesn't work there, or something different happens there. You have to pinpoint the root cause. So yeah, users, not us. Oh yeah, and there is some statistics. Google has brought that, so I have to explain that. It basically means that if you have well-engineered software, meaning your Java application works perfectly fine, it's like echoing one message and it can't break. For any reason, it will not break like ever, because you coded it perfectly. And if you are hosting this on like some server, virtual machine or something, then you can achieve only 3 nines. 3 nines in terms of reliability means 40 minutes of downtime per month. Why is that? Because this virtual machine will go offline, because there will be a network glitch, because memory will be out for some reason, because your neighboring virtual machine will eat your all resources, etc., etc., etc. So you can't get more than this, having perfectly developed software. But if you have perfectly developed operations, then you can have 4 nines. How to do this? You can hire operation teams, or you can host yourself on some clouds and have these auto-scaling features, etc., making sure that your stateless instances are behind load balancers and they are always up, etc., and they are distributed across regions, etc. 4 nines only. Or maybe not only, but it's enough, 4 minutes per 1 month. And when you have perfectly developed business, meaning your business is earning monies, lots of monies, then you can achieve 5 nines, and that's 24 seconds. And why is that? Because reliability costs and might cost a fortune. If you would like to get to 5 nines, then you have to work on self-healing protocols. Then you have to attach self-healing protocols to your monitoring. Then you have to test that. You have to have performance teams. You have to have reliability teams, etc. And that costs. So your business have to have this money. It has to provide this money. But maybe 4 nines is fine for you. I mean, maybe you just work, no, it's not just, sorry. Maybe you work for a service, for a company, which services are okay with 4 minutes of downtime per month, like online shop or something. I mean, my bank, when I have all my monies, not all, but some of my monies, it's down like every second weekend. And I'm completely fine with this. And they are down for a couple of hours. So where are they? I mean, they are even, maybe 2 nines, I don't know. So it's perfectly fine. Yeah. And above that time is the error budget. Time check. OK. And about error budget, it basically means how much time you agree on running your applications in downgraded mode or having it offline. I'm going to get there in a few slides. SLA. SLA simply is an agreement between you and your customer on downtime. You agree with your customer on how much downtime is OK for you and for your customer. So, for instance, if you tell them 15 minutes of downtime per month and they tell you, OK, fine, that's cool. You can get to that number. And above that number, there are some consequences. SLOs, it's measurement characteristic. So basically, if you have this SLA for 15 minutes or something, then you have to somehow measure it. How to measure these 15 minutes. You can have availability-related SLO throughput or something like this. So for instance, if this is 15 minutes, so SLO would be for availability, and that's all. And then you've got these SLIs, which are basically monitoring checks for those SLOs. If you have SLO for availability, you have to measure it somehow. So service level indicators are basically those monitoring checks which pings those services every seconds, every couple of seconds or something. And then there is this error budget, meaning if your application is doing fine and you are not getting into this error budget, then maybe reliability-related work is not needed at all. I mean, maybe this application is working fine, then no need for this kind of work. And if you are getting close to this error budget, to actually overdoing this error budget, then all hands on deck, because probably in a few minutes there will be a problem. I mean, sometimes it's like you've got, I don't know, 30 minutes of reliability of SLA, 30 minutes, let's say, and then restarting applications takes 5 seconds. So if you multiply this 5 seconds by 30 restarts, you know that it's gonna be fine during this month. So whatever, we don't work on that. And that's cool. Also, error budget could be about how much time does it take to get the response. For instance, you can have in SLAs that all responses or 95% of the responses should be under 1 second. And 5% might be over. So you have also to measure it. Also, about SLOs, SLAs, error budgets, important thing is that those should be splitted between services, because not every service have to be like 100% uptime. Cassandra, probably yes, because it's a core service. But some food delivery application for developers, it can be down for like 12 hours where they're offline. So, okay, so put it there and create some kind of table where you specify SLAs, SLOs, allowable downtime, error budget, etc., etc. That's a good way. And when I talked with business about this whole reliability stuff, they told me, actually, one person told me, okay, Maciek, so we would like to have this, I would like to have this error budget and SLOs on some kind of dashboard, so I can see how close we are there, how close, how close. So this is not our dashboard, this is copy-paste from internet, but it could work like this. Our dashboard is not that cool, so I couldn't brought it here because it's so, okay. So I think this is this is the last thing of this theory of SRE in a couple of slides. Toil. Who from you, from Polish speakers, knows this word in Polish? Native speakers, yeah. Okay, it's znój. I mean, I didn't know that, and I was searching for this. There is this word, znój. Yeah. So basically, toil is this all manual work that could be automated. And manual, repetitive work is basically a waste. It's defined as in those books as a waste. So it should be removed perfectly by automation. However, I have to add this here because my work is like 80% automating stuff. Not always automation is viable. I mean, when there is a situation when it takes time to automate, and you do this every 2 months, every 1 month, maybe, just maybe, it's better to have it done manually by someone. Sometimes the level of complexity of automation is rising like this. So just think twice before you automate something. And don't create your own automation tools, please. I mean, it's 2019. We've got Chef, we've got Ansible, we've got Puppet, we've got whatever else. Don't write automation in Java, please. I mean, at least for cloud services, etc. Okay, so after reading all those books, doing that course, and speaking to people, and bringing up all my experience, I was thinking, I mean, yeah, that was let's say, me. How to work on this reliability stuff in code-wise. First of all, I couldn't ask them, please do read books. I couldn't ask them, please do stop using this monitoring service which sucks and you created this and why did you do that? I couldn't. I just have to have some buy-in. So in this DevOps culture, let's say, I created a meeting. Meeting is a thing that solves all people's problem, yeah? And to this meeting, I had to invite some people. Which people to choose? How to choose people for that kind of meeting? There is this thing called reliability mindset. And this is something that some people have this. Those are those people who are actually very interested in how things work. So if they work on application, it's not like they will just push the feature, commit the feature, and that's all. They will be interested in how this feature works on production in that environment, and they will understand this. They will keep asking, etc. They will keep asking how it is monitored, etc., etc. So after 1 month, when I already knew people, then I knew who to ask. And if I didn't know, I just asked others people, and they helped me with that. So we actually choose 1 people from each service, and then we gathered, and I asked them some questions. So just put on the cards reliability-rated stuff you think is rated to the reliability. So they put their self-healing, monitoring, high availability, etc., logging, etc., etc. We grouped those, and then we vote for what's most important for your applications at this time. First thing, self-healing, 7 votes. Why is that? Because they are on call. I mean, if they weren't on call, they may be logging or something, but they're on call, so they want to sleep well, so they would like their applications to self-heal in the perfect way, in a very fast way. And that's why the second thing was improve monitoring. Why? Because when you are woken up during night and it's not self-healed, then instead of having notifications like server number, blah, 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 is down, you would like to have information, this service is down because of this and this and this. It's very important, and it's a huge difference, because if you have notification that this server is down, or this cache is down, or something, then you know nothing. I mean, is it important? What kind of server is this? What happens when this server is down? I can't remember. It's 3 a.m. I don't have a fucking clue. So please do tell me what I have to do right now. So instead of doing this, you have a full description of what's happening and how to work on this. And we didn't have that in our cool monitoring solution back then. Yeah, and there were some other things. Also, moderator is needed for those meetings. I mean, if there is no moderator, then people will stop gathering every week, every 2 weeks, or whatever. Or they will keep talking about some bullshit. So I was the moderator, and there is the list of meetings we had. Hello world, where to the roadmap. So bullshit meeting is first 3 about what SRE is all about and how to work on this. Then we had 3 meetings about self-healing. And at those meetings, we were discussing, at the first meeting, I told guys what is a self-healing, how it might work. Then they were describing around how this self-healing works in every service. So here we've got auto-scaling groups, here we don't have self-healing, and that's fine. And here we don't have self-healing, and that sucks. And we created a special catalog. You're going to see it in a few slides. There was also about infrastructure as a code. So instead of clicking in the UI of AWS services, start using Terraform or anything else. And then we run also the Terraform workshops. Terraform is a tool for automation of the cloud services, let's say. And then planning for the failure, that was the meeting about, think guys, what could go wrong with your application, and what's the possibility of this? And if you are prepared for this, and if you are prepared, I mean, you think you are prepared, then run this scenario on production, and we're going to see if you are prepared, or at least on test. Yeah, we're going to get there also. Postmortems. Postmortems, how many of you run postmortems, guys? Raise your hands. Okay. Postmortems are meetings that are run after outages, after severe outages. My personal opinion, don't run postmortems when business was not affected, simply because there is no need. Do discuss this with teams and services involved, and do write some document afterwards. Okay. there was no money lost, no customers saw that, no customers were affected. And the question was, what do you mean that business was not affected? We discuss those not affected issues on those meetings, because there's the place to discuss those. If we had a problem with some service, one of our service, then guys described how it happened, why this happened, and then others learn, because we all work in very similar environments, so maybe it will happen to some other people. So yeah, that's the way how they are learning from each other. And do run postmortems in the blameless way. So basically, problem is the problem, not the people. And there is this, our service catalog. It's just a tiny part from our infrastructure team, Cassandra, etc., etc. We've got here the severity level of this service, so what's important, what's not, how we provision this, where is the repository, how it is monitored, how alerting works, whether there is self-healing or not, and description for this self-healing, whether we run fair use scenarios, etc., etc. And every other meeting we add columns. And why this is important? Simply because, I mean, there are a few things. One thing, when we work on new service, then this is the starting point for developers. They can take the best working themes from here, from other services, and apply it to their own service. So, yeah, lesson learned. Also, when there is a new person in our company, he can learn reliability from this very sheet. And it's very easy to maintain because people do that, not one person or something. Okay, and you can copy-paste that. You have to have, if you would like to go, to start your adventure to this reliability-related work, site reliability, etc., you have to work with your business, closely work with your business. And that is because without buying in business, you won't have time for this work. I mean, business tells you what to work on, not ourselves. Yeah. So first of all, we run a presentation like this, but for business people. And this was the invitation. We work on this for some time. You can copy-paste it. Then we also discuss with business. There are possible buy-ins. How to discuss with business people why reliability-related work is important, and this way of working on reliability is important. Also, please do copy-paste. What we learned also, that there are many perspectives, not only 3, probably more. Developers understand reliability other way than team leads, technical leads, sometimes, and other way than business. That's why it's sometimes it's good to actually discuss those topics separately between them, and then build in your head the image of how they understand this, because maybe then you will assemble this somehow. Maybe you will see that they thought differently than they, and then you can meet with them once again and discuss those problems. User journeys. How to work on those SLOs, because you can have SLAs or not. We don't have SLAs because we didn't have that need, but we have SLOs in some services. How to work on this? In order to create SLOs, it's cool to actually define user journeys. So the paths that your users get through using your application. And the best people to ask about those users' journeys will be business people, because they perfectly know how your application works. For instance, you can, as a starting point, that might be an index page, then a user enters some search query. So the search query will be the next page, and the next page will be the product page when they click those. And SLOs for that would be time to generate the index page, time to generate results, and let's say time to generate the product page. 3 SLOs, not 5, not 550, just 3. Why is that important? Because when your business have monitoring in place, and this monitoring tells him that time of generating the results page is above some level, then it's very easy to actually discuss with you. Hey, listen, this SLO is problematic. Can we do something with this? And if you have like 50 notifications instead of 3, then you don't know nothing. I mean, then you know nothing. having 50 notifications during night tells you also nothing. I mean, you are completely lost. So less is better. Okay, let's skip this. Observability monitoring. I'm getting faster and faster simply because we don't have much time. Self-healing, this is very important. How to work on self-healing? First of all, gather all your procedures from every place you have. I mean, procedures from this team and that team, etc., in one place. Can be whatever, can be Jenkins, can be Rundeck, whatever, and automate those procedures somehow. Work on this automation, and then test it manually before you attach it to any kind of monitoring. If you test your procedure, Jenkins job, Rundeck job, whatever, many times, then you build trust with this. I mean, I wouldn't like to have removing Cassandra node automated in the first place, but after 5 months of running manually this job in the Rundeck, then I can live with this because I know it works. I know that it's not doing any problems. So yeah, build trust, attach automation to monitoring, and that's profit because it's a solution for self-healing. Of course, it's not that simple. Yeah, we just did that. Basically, we did that for Cassandra. We run Cassandra as a service way. So basically, everyone can spawn their own Cassandra cluster from any backup, and he can do something there. Keep it simple. Really, if there is no need for Docker and Kubernetes, just don't use Docker and Kubernetes. I mean, it costs a lot of money to have Kubernetes operational. I mean, if you can afford that, then yeah, sure, totally go into it. But yeah, and we do the perf tuning per instance type, but already told you that. Operational flows for Cassandra, basically those were all the operational things that we did on Cassandra, that we run on Cassandra, like replacing that instance, repairing key spaces, etc., etc. We automated this, and anyone can click that. Monitoring can also click that. This is a screenshot from Rundeck. Rundeck is like Jenkins part for operations for operations side. Yeah, preparations for the inevitable future. It means if something might go down, I mean, might fail, it will fail someday. So basically, bring those scenarios that keep you away from sleeping, bring those somewhere, put those somewhere, and then work on those scenarios. I mean, run those scenarios on some environment and see whether you can or not can recover. Drills are not necessary. You can run workshops, reliability-related workshops. One of idea is that you take one of those scenarios here, and you don't tell people. You just work on this like on RPG game. So you tell them, okay, it's the middle of the night, and there is a notification server BBB is down. What do you do? And guys, without any computers, just on paper, they try to solve that feature, and you are kicking them more obstacles. Just more and more. And you see what is their level of understanding the reliability-related stuff in terms of that service. Okay, that was this is a project from that GitHub repository I told you. Review regularly, that's very important. Meaning, for instance, right now, I'm putting Cassandra in maintenance mode. Basically, people will maintain those, and I will be just working on something else. But instead, in order to have this maintenance mode, you have to review regularly what's happening. So some charges, etc., etc. What exactly means reliable enough right now? First of all, after this maintenance mode, I will be working like 1 hour per 2 weeks on reliability stuff for Cassandra. It's not much at all. Second thing, for the last 1.5 years, Cassandra didn't page us, didn't wake us, didn't call us at all. So yeah, it's something we can call reliable. And the latencies are also cool. They are very low, meaning this yellow line is 99th percentile. So it's jumping. And this one is 95, so it's like 2 milliseconds in 95 percentile. It's cool for write, but for write Cassandra is very fast. But for read is also very fast. Remember, if you have no operations teams, then in first order, run your services on managed services. So don't host your own database. And if you have to do, go through all those you heard here today and run this as a service. So basically, if you would like to run your Cassandra, etcd or whatever, make sure you can write it as a service. Anyone can just spawn it, and yeah, and it's in a very quick time. And yeah, and I think that's all. Some URLs that are very interesting, and empty slide. Thank you. Any questions?
There's no questions, yeah? So that was Maciej Lasyk.
There is one question.
Okay.
What's your favorite system D feature?
Okay, what's my favorite system D feature? My favorite system D feature is system D. It's a huge subject, so it's hard to answer just with one thing.
More questions? Sure. Okay. Oh.
Can you show the link slide? Actually, yes, I can. Those slides will be at my Twitter in like 5 minutes, so you can download them.
So thank you, Maciej.
Thank you.
That's a very brief and, of course, interesting presentation. We will see in 15 minutes.